Okay, so now we are going to talk about subnetting. Okay, so far we talked about class-based addressing, where we have class A, B, C, where each where the network part has certain fixed bits and the host part has some bits, right? Class A has 8 bits for network part and 24 bits for the host part, and so on. So now with subnetting and the next one you're going to see, which is CIDR, CIDR, both fall under the category of classless addressing. So which means you're not going to strictly follow the class-based network part and host part, the fixed number of bits for the host part and the network part, especially for the host part. Okay, so as we'll see now. Now, as a motivation, consider a scenario where you want to support a network with 9 hosts. Now, if you go with the strict class-based addressing or class full addressing, you would end up choosing a class C network, right? So class C network is the smallest network that you can choose for a network to support 9 hosts, right? So, but a class C network with 8 bits for the suffix part can support up to 254 hosts. So there's a lot of inefficiency over here. You need to support only 9 hosts, whereas you are going to end up with a network that can support up to 254 hosts. So your efficiency of the IP address assignment is 9 over 254, which is just 3.5%. So can we do better, right? So the idea is I'll give you a class C address space, okay, and we will try to make use of that, reduce the number of bits you allocate for the host part and support more what is called subnets. Okay, so let's understand this through a problem. So let's say we have an organization that needs to support 3 departments PQR, and the departments PQR need to support 30, 10, and 47 hosts, right? So the thing is, each department wants to be in its own broadcast domain. Remember, if you when we talked about the motivation for moving from layer 2 to layer 3, I said in layer 2 we're just using a MAC address, the hardware address. You cannot distinguish between broadcast domains. So if I want to send a message from one LAN to a specific LAN, a broadcast message from one LAN to a specific LAN, I cannot do that with just a MAC address, because a broadcast MAC address is what? Let me use it like this. Let me just draw lines for LANs. Okay, so this is, say, your layer 2 switch. Okay, so here we have LAN A, LAN B, LAN C, and LAN D. So if I want to broadcast a message from LAN A to LAN C, if the only broadcast address I know at the MAC level is all Fs, right? So if I use this, the switch is going to forward the frame to all these 3 LANs. If I want to broadcast from LAN A to LAN C, the frame will end up going to all the 3 LANs B, C, and D. So that's the best we can do with layer 2 the hardware address. So that's the motivation for us to go for what we call, where we can distinguish between the different LANs by looking at their forwarding address. So we with the IP address we can find out where each machine is connected to, which network to which each machine is connected to, right? So like this, we want to have each of these departments in their own broadcast domain. So if I want to send a message to a particular department, that message should go only to that department, not to everything else. So that's why we need to kind of divide this address space to 1246.98. This is a single address space I've given you. So this is a class C address space, right? So by itself it can support, it's our 8 bits for the host part up to 254 hosts, but we do not want to allocate all the 254 hosts for one of these departments. We want to divide it among these departments, okay, and create what is called subnet and put each subnet in a separate broadcast domain. That's the motivation. Okay, so let's see how we go about doing it. The first step is to find out the number of bits you need to support each of these hosts. So if we have 30 hosts, right, to support in P, how many bits we need? That's going to be 5. Why? Because we know according to our rule all the bits in the host part cannot be 0 or 1. Still 2 to the 5 is the number of hosts we can have, minus 2 according for scenarios, according for what? Not having all bits 0 or not all bit 1s, right? So still 2 to the 5 minus 2 is going to be 30. Whereas if I want to support 31 hosts, right, if I wanted to support 31 hosts, I would need 6 bits. Why? Because 2 to the 5 minus 2 is going to be 30 hosts. So with 5 bits I can support only 30 hosts at most. Alright, so this negative 2 again refers to what? Having all bits, all the host bits 0 or 1s. Okay, now to support 10 hosts, how many bits we need? We need 4 bits, because 2 to the 4 minus 2 is going to be 16 minus 2, so we can support up to 14 hosts with 4 bits. Now for 47 hosts we need up to 2 to the 6 minus 2, because that's going to be 2 to the 6 is 64 minus 2, that's going to be, we can support up to 62 hosts with 6 bits. So that's the first step. So you need to find the maximum number of bits you need to support each of these departments. So now you take the maximum among these, that will come out to be 6. Maximum among 5, 4 and 6 is 6. Okay, so that's what you will end up having. So what we'll do is we'll like this is our class C address that I gave you, 212.46.98, okay, .0, so the last 8 bits. So we are going to use not all the 8 bits for the host part, we are going to use only the maximum among 5, 4 and 6, which is 6 bits, right? So we are going to use only the last 6 bits for the host part. Okay, and now you see you have 3 subnets. So again, going by the binary arithmetic, if you want to support 3 subnets, how many bits you need? You need 2 bits, right? So the subnets could be represented as let me pull up something here. The subnets could be represented as 0, 0, try to make this typewriter. Okay, let's see. Okay, so this is 0, 0. This is going to be 0, 1. This is going to be 1, 0, coinciding with 0, 1 and 2. right? So we can actually support another subnet also if needed, so that gives flexibility to grow the organization, because we are going to allocate 2 bits for the subnet part. So we can really support 4 different subnets with numbers 0, 0, 0, 1, 1, 0 and 1, 1. We don't have nevertheless the last subnet. Okay, we have to support only 3 subnets in this case, but still we'll leave it open for future growth of the organization. Okay, so we are going to use the remaining 2 bits among this 8 bits for the host part for our subnet now. So if we needed more subnet or more bits for the host part, we have to go towards the left, which is in this 8 bits here. But I've come up with the address space for this example to keep it simple for you to understand the basic principle of subnetting. Right, so what we are going to do is, as I show here, we are going to use 0, 0 as the 2 bits for subnet part. It's fixed for subnet P. 0, 1 are the 2 bits for subnet Q. 1, 0 are the 2 bits for subnet R. So once we do that, we need to come up with these 3 things for each of these subnets. The first is called the subnet prefix or the subnet address. So what does it mean? It's equivalent to a network address. In a network address, what we'll say, it indicates or identifies the network, not any host in the network, right? So likewise, the subnet prefix or the subnet address identifies a particular subnet, not any host within the subnet. So how do we get the network address? By putting all the bits for the host part to be 0. Similarly, we can get the subnet prefix or subnet address by putting all the bits in the host part to be 0. So if you put all zeros over here, that will be the 6 zeros for the host part combined with the 2 zeros for the subnet part. So together all the 8 bits will be zeros. So if I just write it like this, 212.46.98.0, it looks like a class C network address, right? If I just write it like 212.46.98.0, it just looks like a class C network address. So how do we now kind of indicate that it is not a network address? Because if I say it's a network address, it can it has to support 254 hosts. So this subnet that we have now can support only up to what? 62 hosts. Why? We allocated 6 bits for the host part, so it can support only 2 to the 6 minus 2, 62 hosts per subnet. So how do we indicate that? So that leads us to introduce a term called subnet mask. A subnet mask is a 32-bit quantity. It's a sequence of ones followed by sequence of zeros. Okay, followed by a sequence of zeros. The number of zeros indicate the number of bits allocated for the host part. Okay, so which means the number of ones indicate the number of bits allocated for the network and host subnet parts. Okay, so in this case, how many bits we have for the host part? We have 6 bits, right? So it will be 6 bits for the host part and 32 minus 6 bits for the which is 26 bits for the network plus and subnet parts put together, right? So it will be how many ones? 26 ones followed by 6 zeros. Okay, so it will be 26 ones followed by 6 zeros. Okay, so 26 ones followed by 6 zeros. Now we are trying to write this in decimal, in the dotted decimal form. That will be 255.255.255 accounting for the first 24 ones, and then we have the last 2 ones followed by 6 zeros accounting for the last 8 bits. That will be 192. Okay, so this is the subnet mask in the dotted decimal form. So now you notice here I indicate the subnet prefix as 212.46.98.0/26. So now you will realize why this 26 is here. The 26 here is indicating the number of bits we are allocating for the network plus subnet. Okay, so the network part traditionally has a 24 bits, and then the 2 bits for subnet, so together they make up 26 bits. So the remaining 6 bits, it also means when I say 26, the remaining 32 minus 26, which is 6 bits, represent the host part. Okay, so now again following the rule that we followed before, for a broadcast address all the bits in the host part should be 1, right? So when we put all the bits in the host part here to be 1, the 6 bits are 1, so you have 0 0 followed by 6 ones, and this in decimal is going to be 63. Okay, so we again write it as 63/26. Okay, 212.46.98.63/26. So this is the broadcast address for the subnet. So if I want to send something to just this subnet, to all the machines in the subnet, then I have to use this along with this subnet mask in the as the broadcast address. Okay. Now the valid range of IP addresses for the subnet. So the subnet address, which is like a network address, is this. This is the broadcast address. So everything in between will be a valid unicast IP address. So you see here, this is starting from 0, right, to 63, isn't it? 0 to 63. That's the subnet address. This is the broadcast address. So everything in between means 1 to 62. So 212.46.98.1/26 indicates subnet mask, then 2, 3, 4 up to 62 are your valid unicast IP addresses. So you can support up to actually only not 64 but 62 unique unicast IP addresses, okay, for this subnet. Similarly, let's do for subnet Q. You have 01 has the 2 bits for the subnet part. So if I want to get now the subnet address, you will put all zeros for the host part. So when I put all zeros for the host part, it becomes totally the 8 bits will add up to 64. So 212.46.98/64 is going to be my subnet address, and the broadcast address you'll have all ones, so you'll have 0 1 followed by again 6 ones, so it is 0 followed by 7 ones, that is 127. So that's going to be a broadcast address, and everything in between 65 to 126 will form your unicast IP addresses. Similarly, for subnet R, you have 10 as the 2 bits for the subnet. So this is going to be now 6 bits for the host part. If they are all zeros, it's going to be 10 followed by 6 zeros. So that is going to be 128, and 10 followed by 6 ones is going to be 191. So that's your broadcast address. This is your subnet address. So everything in between 129 to 190 will form your valid unicast IP addresses. Okay. So let's go through another example where we have now 5 departments or divisions, each one requiring to support 10, 15, 20, 25, 30 hosts. Okay, so these are the department or subnet names, and these are the number of hosts you want to support. So again, going by our binary arithmetic, to support 10 hosts we need 4 bits, right? 2 to the 4 minus 2, you can support up to 14 hosts. Then 15, you see, you can support only up to 14 hosts with 4 bits. So to support 15 hosts, we need the next larger number, which is 5 bits. Similarly, 20 hosts, you got 5, and so on. So the maximum among this is 5 bits. So which means you're going to use the last 5 bits of the network address space for the host. And now we need 5 subnets here. So to support 5 subnets, we need 3 bits, right? So it's again given to you accordingly, such that you can use the 8 bits in the network address space. Okay, so this is a class C address given to you, 202.45.80.0. So you can use all the 8 bits in the address space for your subnet part and the host part. So we'll use now these 3 bits for the subnet part. So again, like going in numerical order, this is 0, 1, 2, 3, and 4. These are the 3 bits for the each of the subnets. Okay. So now the first thing that you'll find out is the subnet mask. The subnet mask is going to indicate what? The number of bits for the network plus subnet and the number of bits for the host part. So here we have 5 bits for the host part. So you'll have 5 zeros, so 32 minus 5, 27 ones. So you'll have a sequence of 27 ones followed by 5 zeros. So if you translate that into dotted decimal form, it's going to be 255, 255, 255 for the first 24 ones, followed by 3 ones and 5 zeros. So 3 ones and 5 zeros is going to be 128 plus 64 plus 32, that is 224. So that's going to be a dotted decimal version of your subnet mask. Now, how to find the network subnet address, broadcast address, and valid range of IP addresses? Just put all the bits in the host part to be 0. If you put all of them to be 0, this will be 3 zeros followed by another 5 zeros, so 8 zeros. So that is 202.45.8e.0/27. The 27 indicating what? The number of bits for the network plus subnet. Okay. Similarly, for the broadcast address, what do you do? Put all ones here. So you have 3 zeros followed by 5 ones. That will be 31. Okay. So 3 zeros followed by 5 ones. That will be 31. So 202.45.80.31. See, if you do it sequentially, it will follow one after the other. Say for now subnet B, it's going to be 001 followed by 5 zeros. So that's going to be 32. And that's what it is. And then the broadcast address is going to be 001 followed by 5 ones. So it is actually 00 followed by 6 ones. That is 63. Okay, and then for the next one it's going to be 64 to 95. This is 64 010 followed by 5 zeros is going to be 64, and 5 ones it's going to be 64 plus 31, that's going to be 95. Okay, and so on. So now everything in between 1 to 30 is going to be the valid IP address range for the first subnet. 33 to 62 is going to be the valid IP address range for the second subnet. 65 to 94 is for the third subnet, and so on. Okay. Now one thing you should also realize is we did the subnet mask thing for classless addressing here, right? Which is like subnetting. Now you can also come up with subnet mask for class A, class B, and class C addresses. The only thing is what in a class A, class B, and class C there's no subnet part. It's only a network part and host part, right? And we know how many bits we have for the network part and host part in each of them, right? For class A we have 8 bits for the network part and 24 bits for the host part. So that will make it to be what? 8 ones, right? Followed by 24 zeros. Okay, so that many zeros. So 8 ones followed by 24 zeros will give us the subnet mask of this. So every class A IP address will have this subnet mask. So if you go with the class based addressing, every class A IP address will have this subnet mask. Okay, so the reason why remember when I said the first bit is a 0 for a class A address, right? The reason why we did that is when a router gets a packet with an IP address, right? It can find out what class that packet belongs to by just looking at the first 8 bits. So if the first 8 bits starts with a 0, it means it is a class A IP address. Okay, so then it can look into its routing table only when there's a match the class A IP address, alright, or class A network address, sorry. Similarly, if it starts with a 10, we know it's going to be a class B IP address, so it can look into that. Right, that may be a small deviation, but we'll come back to this when you go into the routing table chapter. But let's now move on to the class B. So class B, we have 16 bits for the network part and 16 bits for the host part. So we have 16 ones, right, followed by 16 zeros. So that will, in binary is going, decimal is going to be 255.255.0.0. So every class B IP address is going to have this as a subnet mask. Now for class C, it's going to be what? You can practice as an exercise. It's going to be 255.255.0. Now you see here, whereas when we did the subnet mask, the subnet based stuff, this all these 5 subnets had this subnet mask, and the previous example we had this as a subnet mask. So once we start doing subnetting, there's no class based addressing. So each network, or like the collection of these 3 subnets, will have their own subnet mask. Okay, whereas here, if we go with a class based addressing, every class A network has the same subnet mask, every class B network has the same IP address, has the same subnet mask, and so on. Okay.